So, sampling and sampling techniques, I said that statistical data can be collected from all the possible units in a system. In other words, all the possible units. We can get data from such. And when we get data from all the possible units, it becomes what? A population. Is that clear? To the extent that the data we have will now be known as population data. Is that clear? But also, we can collect data from a selected number of units from all the possible units in that particular system or in that population. And when we have that, we will now say that we have what? A sample data. So we can have a population data, we can have a sample data. Now, what is now sampling? Sampling, therefore, is defined as a scientific method of selecting and using a representative part of a population to seek the truth that exists in that particular population. That is a sampling. In research, data collection involves two things, namely sampling and survey, known as sample survey. And how do I mean? That data collection involves two things, sampling and what? Survey. And that is known as a sample survey. And what is sampling? Yes, of obtaining what? A sample from a given population is what? Sampling. Is the process of obtaining a sample from a given population. And what is a sample? A sample is a fraction of a what? Of all the units in a population. So that is a sample. The process of getting a sample is sampling. So when we have obtained a sample, in other words, when we have carried out sampling as a process, we will obtain a sample. Now, when we now get to interview those samples to obtain the information that we need, that now becomes what? A survey. Is that clear? So when we combine the two, it becomes what? Sample survey. If we are conducting the survey from a sample, that's all that we do in research. We conduct a sample survey. First of all, we go into sampling to be able to do what? Get a sample. And when we have got the sample, we will get the information that we need from the sample, and that is survey. So sample survey, this is defined as the collection and the examination of data from a sample in order to make inferences about the population. That's what we know as sample survey. Hence, sample survey theory deals with the process of sample selection. That's number one. It deals with the process of what? Sample selection. After that, it deals with the process of what? Data collection. And when we have done that, it deals with the process of what? Estimation of the population characteristics of interest using the sample data. And after that, it deals with the process of determining the accuracy of the estimates. When we have done this, we have concluded a sample survey. So there are four aspects of sample survey. Number one is to select a sample. Okay? To select a sample is number one. Number two is to collect our data from the sample. Then number three is to estimate those characteristics that exist in that population from the sample. Then number four is to be sure that the estimates that we have obtained are what? accurate. There are the four things involved in sample survey. So we study statistics as a branch of science because of the theory of sampling. It is because of the theory of sampling that we study statistics. We don't study statistics because of that we are getting mean median mode. That's not why we study statistics, but because of the theory of sampling. Because we will need an appropriate number of units from a population that can be used to study the entire population. And having said that, we will look at the sampling techniques. We have so many sampling techniques in statistics, so many of them. And even as we continue, some researchers are still working very hard sampling. As simple as it is, there are experts in statistics who have professors of sampling. Everything they have devoted their life to do is what? Sampling. To to do is to discuss sampling, which I have told us is the process of collecting a sample or process of selecting a sample from a population. That is everything they do. All the publications they have is geared just on that, selecting sample from a population. But it's a very important aspect of statistics, because the reason is because the type of the method of sampling that one is using for a particular study determines how well the output or the result will be. Is that clear? In other words, if one uses a wrong technique in his research, the finding of such a research cannot be correct. Is that clear? There's no how somebody will use a wrong technique of sampling, and at the end, we obtain a very beautiful output. It may appear to be very beautiful, but when somebody sees it and faults the method of sampling, what it means is that every other thing that you have done is what? Is wrong, because the method has been faulted. And that is why it is very important. So we are going to discuss sampling techniques. So there are two broad types of sampling techniques. There are two broad methods of sampling in statistics, and they are known as probability sampling and non-probability sampling. What is probability sampling? Let's start with that. Probability sampling is also known as a random sampling. And it is the type of sampling where every unit of the population has a non-zero probability of being selected in the sample. I said that it is a type of sampling where every unit of the population has at least a non-zero chance of being selected. Is that clear? There are situations where in our study, in our research, we will restrict some people from being participants in our study. Is it true? There are, even though they are part of the population we are studying, but we decide on our own. These ones will not be what? Part of the study. Is that clear? Is such a thing possible? Okay. So if it is possible, what it means is that those ones that I have decided they are not going to be part of the study, they don't have a chance of being selected in the study. Is that clear? As a result, such is what? It's not a probability sampling. It belongs to non-probability sampling. Later we will come to discuss those non-probability sampling to begin to ask why should we say that we don't want to include this one in our study. But what we are discussing is probability sampling. So any type of sampling that one is doing, where every unit of that particular study population has a chance of being included, of being a participant in the study. Such sampling is what? Probability sampling. And there are different types of probability sampling. The commonest one is the simple random sampling. That is the commonest probability sampling. If 20 persons are carrying out a survey, I'm sure that more than 10 of them will be making use of simple random sampling method. But sometimes there are situations where simple random sampling method is not an appropriate method of sampling. And if one goes ahead to use it, it means that the sampling method has been faulted. And because it has been faulted, the result is equally what? Wrong altogether. So, but what is simple random sampling method? In simple random sampling method, each unit of the patient or being included in the sample. Is that clear? All the units have equal chance. So when we are doing that, we say that sampling method. And of course, we know the various ways. There are various ways we can carry out a simple random sampling method. The simplest way of illustrating simple random sampling method, which if it were to be in a classroom that we are studying simple random sampling method, we will always take a green from lottery. I don't know how many of us have witnessed a lottery play. Do you know what I'm talking about? I'm talking about the physical, maybe lottery, where we will have tickets that are sold. And all those tickets that are sold, maybe there are 1,000 of them that are sold. All of them will be what? Put in a container. As they are put in a container, the people that are organizing such a lottery will make sure that every unit will have what? The same chance of being the one that is picked. In such a situation, maybe they have prizes for numbers 1 to 10. Is that clear? Out of the 1,000 tickets, there are prizes for only what? Prizes 1 to 10. Which means, out of the 1,000 tickets, 990 of them goes without price, any price. But only 10 of them has what? Price attached to. What they will do is that when those 1,000 tickets are put in a basket or in a container, they are reshuffled and reshuffled and reshuffled to make sure that anyone that is going to be picked is not being picked out of preference. It's going to be picked by chance. So the essence of the shuffling and reshuffling is to give all of them the same chance of being the one that will be picked. So after series of reshuffling, one will just dip hand and pick one. And that one that is picked is selected. Is that clear? It is reshuffled and reshuffled and reshuffled again. Another one is picked. That one that is picked is selected until the 10th one is selected in that way. That is just a practical demonstration of simple random sampling. It is done in such a way that all the units have equal chance of being what? Selected. I hope it's clear. But there is one thing that makes simple random sampling a good tool in a research, random sampling method in a research. And that is the next thing that is said there, that it is employed in a homogeneous population. What it simply means is that if a population of a study is not homogeneous in nature, there is no way that you will use simple random sampling method and it becomes a good sampling technique. And what do we mean by being homogeneous in nature? What we mean is that depending on the variable of interest in that particular study, all the units are homogeneous. There is no difference in them with respect to the variable under study. Homogeneity of a population is defined in the consideration of the variable under study. I don't know if it's clear. Let me try to explain that. If I am carrying out a study and my study variable is maybe gender, is a very strong variable of my study. And I come to a population where all the individuals I have there are maybe males. It means it's homogeneous with respect to what? Gender. Is that clear? But if gender is a strong variable of my study, and in the population of the study, I have both males and the females, what it implies is that that population is what? It's not homogeneous with respect to what? Gender. And if I go ahead to employ simple random sampling method, by chance, I may, assuming I want to use 200 individuals, I want to recruit 200 participants in the study. Do you know it is possible? I will select the 200 individuals I will select may be males. Is it possible? It is possible. And if I do that, I have excluded females in that study, knowing fully well that the variable of a study, that gender is very important. It is equally possible that out of the 200, I have selected, using simple random sampling method, 150 females and only 50 males. Is that clear? And when I have done that, I will go ahead and carry out the study. But it is not correct. Why? Because Gender is important in that study. And because gender is important in the study, and I have looked at the study population, there is heterogeneity with respect to what? Gender. And as a result, I cannot use simple random sampling in such a situation. I hope it's clear. So, for me to use simple random sampling, the entire population must be homogeneous with respect to the variable under study. So, in this very population that has males and females, which means they are not homogeneous with respect to gender, they may be homogeneous with respect to some other variables. For instance, it may be that we are studying maybe human beings. It may be that we are studying children within the age bracket of 0 to 1. Is that clear? So all the children within the age bracket of 0 to 1, with respect to age, they are what? Homogeneous. But with respect to gender, they are what? Non-homogeneous. Is that clear? So in such a situation, because we have ab initio defined that the people that want to study are from 0 to 1, therefore, with respect to age, they are homogeneous. But with respect to gender, they are heterogeneous. So because of that, if gender is a very strong variable that I'm considering in my study, I cannot use simple random sampling method there. If I do that, I will be wrong, because the result I'm going to get may not be correct. And if the sample I have is wrong, then the result will equally be wrong. The next type of sampling, probability sampling method, is stratified random sampling method. And the stratified random sampling method is used when we have a non-homogeneous population. If we want to study a non-homogeneous population, then the best sampling technique that our mind will be going to should be stratified random sampling technique. And what do we mean by stratified random sampling technique? It is a sampling technique where the entire population is grouped according to what? Homogeneity. Is that clear? Like in that example where I gave, where the study variable is gender, we will first of all group the population according to gender, where we will have the group of males and the group of females. Is that clear? So when we have these two groups, in stratified random sampling, what it does is first of all to group the entire population into what? Smaller homogeneous groups. And when it has done that, we now employ what? Simple random sampling method into each of those groups that are now known as what? Strata. We employ simple random sampling method into each of them, so that assuming our sample size is 200, we may decide, let us have a group of males and a group of females. And when we have grouped them, we may now decide, let us select 100 from males and 100 from females, so that when we put them together, it will be what? Equal to 200, which is our sample size. Is that clear? Then, so that we will now have them and they will begin to study. The reason is so that we will be able to have equal representation. I hope it's clear. I don't know. Sorry, let me check what I have. Okay. I wanted to check if what I wanted to say is contained in another slide, but it appears it is not in any slide, so I will have to say it. Let's look at this. I said the population is first stratified into homogeneous populations, so that simple random sampling will be employed in each subpopulation to select some units of the population into the sample. In this way, a combination of all the units selected from each stratum forms the sample. Now, it is important that we say this because the essence of stratification is for what? Equal representation. Is that clear? That is the whole essence of stratification. But then, when we are talking of equal representation sometimes may not mean equal number of persons or participants from each stratum. I don't know if it's clear. I want to repeat it again, that equal representation of every stratum does not always mean equal number of participants from each stratum. It does not always mean that. There are some other ways that they can be obtained, even though we don't have equal number of participants in the study from each stratum, yet we have what? Equal representation. Does it make sense to us? Or maybe I will need to explain that further. For instance, we are still talking about that gender as a study variable. We come to a population, we have stratified them, and we have seen that equal representation of these two strata. Somebody may say that equal representation here should mean I will select what? 100 from males and 100 from females. If I do that, have I equally represented them? I have not, because ab initio we have not known that the females are more in number. So when I have equal representation, that's what I meant by saying equal representation does not mean recruiting equal number of persons from each stratum. Is that understood? So I said there are different ways of determining the number of units to be selected from each stratum, also known as allocation of a sample size to strata. But in all those methods, there are two most commonly used methods of allocating sample size to the strata. And those two methods are, number one, equal allocation of sample size to strata, while number two is proportional allocation. They are the two most commonly used methods. Is that clear? But I want to say here that in order to make for actually equal representation, proportional allocation is better than equal allocation. Is that clear? So like in that population of 1,000 persons, where 700 of them are females and only 300 are males, where I want to recruit a sample size of 200, equal allocation means select 100 from males and 100 from females. Then you have your sample size of 200. But proportional allocation simply means select 70% of the variables. So 70% of the 200 should come from where? From females, while 30% should come from males. That is the actual equal representation. I hope it's clear. So I want to recommend that as we go to the field, we should make use of proportional allocation more than equal allocation. It is only where proportional allocation is not possible, because there are cases where it may not be possible. In such a situation, you can use equal allocation. Is that clear? What I mean by not being possible is that, in fact, there is no place where it is not possible. There's no, it is actually equal allocation that may not always be possible. But proportional allocation is always possible. Equal allocation may not always be possible. And how? It is true because in equal allocation, if I have maybe in that population of 1,000 persons, and I want to use equal allocation to select 200 individuals, which means 100 will be males and 100 will be females. What if in that population I have only 70 males and 930 females? Do you understand? Sorry, 930 females, yes, with 70 males. Can I select 100 males from such? I cannot. So in that case, equal allocation is not possible. So by and large, in everything, I have better representation of a population, and it should be recommended. There are so many other allocation methods. In fact, it is even till now, it is sample research. Those people in sampling that I have talked about, some of them are discussing this proportion allocation of sample size to strata. It may be something that someone is publishing. And even today, we still be looking at those methods that are in existence, and they are saying that this one is in existence, but it doesn't make for this. This other one is in existence, though it makes for this particular thing, but he did not consider this. And as a result, this and that. And such a person will come up with another method. So it is open research. But these two are the most commonly used ones. You have a question? Okay.
$370, and I try to look at that population to be able to keep them in stratas. Now I now notice that, let's say population of nurses is 250 in the whole population. Doctors are 100. I was checking it per department, and I discovered there is a department that they only have 3 staff there. And it's giving me a concern, because I don't know how to, in terms of proportional allocation, how do I go about it? Because if I said now I'm going to use 10%, it may not carry the whole number. As in, it's my problem, short. It's my headache now. So I don't know how to come out of it.
It's your headache now, and the headache is still there. Even with all that I have said, that headache has refused to go. You said? I don't handle any drug. Okay, let's try to maybe speak into the case that she has presented. We are talking of, I have said that proportional allocation is recommended, and she has presented a situation where maybe she is trying to do proportional allocation, and she has said that in some departments they are few in number. It is because they are few in number that proportional allocation should be the best allocation that can go there. If we have actually don't pick only one person, maybe the department that has only 3 persons, for instance, it is possible that it's only one person that will be qualified to be recruited in this study. Stop, don't distract her, please. Did you get what I'm saying? If I understood your case. So, in a department where they have 3, what you need to do is the percentage of that particular, the percentage of the population will be included in the sample. It is possible that only one person eventually will be recruited into your study from that department. But maybe you have a further information. You were raising your hand. Maybe you have a further information to give.
Did you use? So the question is now, are you now doing different percentage for each of the units?
You hold on. Now I understood I have understood your question now. Before I did not understand your question. The percentage I'm sure that you are making reference to is the sample size that you are studying. And maybe you have made mention that I want to study 10%. Okay? Let's assume that. Is that what you are saying? Ha. Mm-hmm. Mm-hmm.
Mm-hmm. Have various departments.
Yes.
So in each of these, I decided to take the population of everybody in that department. Let's say in medicine and surgery, the doctors, their population is 100 in the whole hospital. And they will be represented in that my 370.
Yes.
In another department is 3. In another department is 2. And you know, this thing had to be consistent. What do I do? Because if I'm going to say, okay, I'm going to do 10% for all the population, what happens to the 3? So please, okay, let me just say I'm not doing anything. What do I do?
Okay. That is a better question. What do you do? Because that percentage, there is no percentage in stratum size. What you are talking about is the only time you have a problem is how do I determine my sample size? That is the problem. But if I have determined my sample size, for instance, as we have said, let us assume that I have used an appropriate formula and I came up with a sample size of 370. Okay? But this 370 is going to be distributed across the various departments. And I have said now that we are using proportional allocation to fill those 370 persons. Is that not what you are asking? The 3 what? 370. What we'll be looking at is the population. What is the total population? Let us assume that the total population is 1,000. Let's assume that. And out of this 1,000, you are going to recruit 370 of them into your study. Okay? But this 1,000, I want to paint a scenario. Okay? Let's assume that there are only 3 departments that you are studying. But in these, out of these 1,000 population, you have 700 from one department, 200 from another department, and 100 from the 3rd department, making a total of what? 1,000 of them. And you are interested in getting 370 out of them. And I said that we are using, for us to use the proportional allocation, we will come from the 1st department. What is the proportion of that department in the entire population? The proportion is 700 over what? 1,000. They have a proportion of 70%. Is that clear? So, 70% you are going to find what is 70% of 370. Okay? Whatever is 70% of 370 will be recruited from that department that has 700. You come to the second department, they have a population of 200. What is the proportion of 200? It is what? 200 over 1,000, which is what? 20%. What it means is that 20%, what is 20% of 370? 20% of 370 will come from the second department. Is that clear? You go to the third department, they have a population of what? 100 out of the 1,000. So what is the proportion of that stratum? The proportion is 100 over what? 1,000, which is what? 10%. That department has contributed only 10% to the entire population of that your study. Therefore, you are going to recruit what? 10% of 370 into your study. So by the time you take 70% of 370 plus 20% of 370 plus 10% of 370, you have what? You have 100%, which is the 370. Let's look at it. We can even compute it here. What is 70% of 370? 70% of 370 is simply 0.7 times what? 370. 0.7 times 370. That is equal to 259. Is that clear? So from department 1, you are going to use 259 participants. Check it, you put it down. The next one is 20% of 370. We have 20% is 0.2. 0.2 times 370 is equal to what? My own is saying 74. So it's 74. So you take 259 plus 74. Keep it. Is that clear? We'll come back. 10% of 370 is what? 0.1 multiplied by what? 370. That is equal to what? 37. So now add 37 plus 74 plus 259 is equal to what? 370. That is your sample size. Is it clear now? Okay. Yes. Okay.
For the first group, this 200 for the first set, maybe nothing that we had 259. How are you going to select this 259 from?
Okay. Okay. Thank you. Now we have, at this point, we have now known the number that we are looking for in each subgroup. Is it not so? Now, in stratify the sampling says stratify the entire population. When you have stratified, use a simple random sampling method to select from each stratum. And what is simple random sampling method? It is a sampling method where all of them have equal chance of being selected in the study. And we have so many methods of how we can apply simple random sampling in real life. It could be, for instance, that you are, assume it is in a hospital setting, and you want to do simple random sampling method. Let us put it in this way so that it will be easy for us. That somebody is studying three different hospitals, okay? And we have the population from each hospital. And what we have just computed is the population of a particular hospital, which is 700, where we are going to select 259 from, using simple random sampling method. Now let us assume that these people are maybe the workers, the staff. Somebody may decide. All you know is that you are going to use what? 259 of them. You are going to recruit 259. And because you are recruiting 259 and it's going to be by simple random sampling, you may decide, for instance, to stand on the gate, at the gates of that hospital. For instance, you are looking for all the staff. It is expected, as you are standing there, all of them have equal chance of passing by at that time. Is it not so? So you are not restricting anyone because it is expected that any of them can pass at that time. So as they pass, anyone that passes, you can recruit that person. You can just ask the person to be a participant in your study. After that, if the person says no, declines, is a different thing. Do you understand? Because someone can decline that I don't want to be part of this study. Once someone declines, it means that that person is what? Cancelled. You continue. As you are recruiting them, once they're up to 259, you stop. You have selected the number that you need. But this recruitment depends on the type of study. There are some that may involve that as you are recruiting, you are equally conducting the survey immediately. How do I mean? You are asking the question that you need to ask immediately. Do you understand? It is possible that you may decide they stay in offices. You come in. Let us assume it is in this place. You may start from the first office. As you knock, you enter. You don't have anybody in mind. You are not restricting another person. Do you understand? If you maybe present why you came and the person is interested to be a participant, you get the information that you need from the person, you move to the next person. So long as it is done in a random manner. What is important is that at the end of the day, you have selected 259. And once you have 259, that is the end for that particular population. You move to another one. I don't know if I've answered your question. He said? I use balloting to explain a demonstration of simple random sampling. But let's look at it. We are discussing real life now. In real life situation, it is possible that you have the names of the staff that you want to, that population. If you have their names, you can randomly select the names that you want and now visit them for the survey. Is that clear? But if you don't have the names and you don't have any means of identification, balloting is not possible in real life. We are discussing real life situation now. I don't know if you understand what I mean. It is only when there is a means of identification. If you have means of identifying them, then you can identify all of them and pull them together and then randomly select the ones you want to select and now look out for them. Do you understand? But where such is not possible, depending on the type of the research you are doing, if it's not possible, you get into the field, apply randomness there. Once you apply randomness, you are not favoring any person against the other. Then you have done simple random sampling. Yes. Hi. I'm not offended though.
By my repeated question, because since the person is studying 3 different departments,
Mm-hmm.
and she is studying nursing,
Mm-hmm.
and under the nurses you are studying, you have ACNOs, you have deputy directors, and peradventure the deputy directors are higher in number than every other. Do you still use a random sampling?
Okay. You have introduced another thing. You have introduced yet another thing. Do you know what you have introduced? You have introduced heterogeneity into that particular group. Therefore, you need to stratify them again. Do you get what I'm saying? You have just introduction to do what? Into the what? Homogeneous groups. But at this point, you have introduced another form of heterogeneity. So you still need to do what? You need to further stratify. Is that understood? Okay. No other question. So we move on. The next sampling method is the systematic sampling. Systematic sampling method. This is a method, or this method also gives every unit in the population an equal chance of being selected. But how is it done? It's different from stratified sampling. It is different from simple random sampling. How is it? He says, I want to use an example to demonstrate that. Suppose a sample of n units, small letter n units, is to be selected from a population of size capital N units. And we want to use the systematic sampling method. The first thing we will do is to obtain what we call the sampling interval. The sampling interval. Let's still continue to use this example. We want to select a sample of 200 persons. Out of it, we use systematic sampling. We will get a sampling interval, which is going to be what? 1,000 divided by 200. What is good? Is say what? By chance. And what it is now 3 has been selected. 8. The third person is selected. The 8th person has been selected. 8 plus 5 is what?
The equal chance to be selected. But if you do it like this, you already know the people you're collecting, so everybody will not be like themselves.
Okay. Yes. This is a wonderful discussion. Now, we have taken two inputs. We want to hear from the third person.
Okay. What I want to say is that when you do it that way,
can we have one house?
if it is done that way, it means that it's no longer systematic. There is no interval in that selection. There is no interval because they are choosing 3. But when we talk about that systematic, there's a progression. From that 3, you keep on adding until you get to what you want. But when you take it that way, you are not going to have that interval. There is not going to be systematic.
Okay. You know, I told us yesterday that academics doesn't know democracy. So let's not begin to think that maybe being years or number that.
That tree was stranded before another life, before the next life, progressively.
Okay. Okay. Do we have any other? There is a hand there.
She has missed what I mean.
Don't worry. Don't worry. Don't worry. We'll come back to you. Let's not rush over it.
If I understand correctly, they are randomly choosing 1, 2, 3. That's they are picking 1, somebody will pick 1, somebody will pick 2, somebody will pick 3. It's no longer systematic. They are basically doing random sampling. Basically what you are doing. It's equal chances for everybody to choose. They will not systematic. They are basically doing random sampling.
Okay. Thank you very much. Now you.
Yes, clarified it.
Okay, he has clarified it. There is a hand there. Hi. There is no democracy in academics.
It's just that first random selection that confused me. That first random selection where you set 3.
Okay.
Because the interval should be set forward.
Okay. Hey. Now, I guess. Does anybody say how they want to say anything? Okay. Now, can we now listen? I think we have brainstormed now. You want me to pass a verdict?
Please, don't be offended. They are mistaking the question I asked. The question I asked is this. You group like, you give number 1 to 5. You are not adding any other number apart from 1 to 5. But this number, 5 is 200, 4, 200, 3, 200. Each number has equal chance of being picked. And the total population is 1,000. So everybody will pick. No number will remain. So at the end of it, you randomly pick a number. Maybe you pick 1 or you pick 2. Then if you pick, you now say, how many people who has number 2? Everybody that has number 2 is included in the study. That's what I asked.
Yes. You have now clarified it. Thank you very much. So can we now, can I say something? Okay. There are two ways. I will say two things on this. Both sides are correct. Let me start that way. Both sides are correct. However, both of them will not be correct if they have the same interpretation. Okay? Having said that, I will now finally put it in this way. Like the way she asked the question, which she has corrected some persons and now brought out exactly the way she asked that question. That way she asked that question, it is not a systematic sample. It's as simple as that. But it can amount to systematic sampling if something happens. And what is that will happen? Assuming they are maybe in a single file, you begin to number them. 1, 2, 3, 4, 5. You are supposed to number the next person as 6. Is it not so? Yes. But you start again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Until you get to the last. And you now do a simple random sampling method. And you pick maybe 2 from 1 to 5. You pick 2 using simple random sampling. Then you now ask, if you are 2, raise your hand. All the 2 come this way. That is systematic sampling. But if you have pulled them in a pool and you ask them, come and pick, there is no more sequence there. Because it has lost the sequence, it is no more systematic sampling. But if it is done in the other way I have presented it, it is a systematic sampling. Do you understand it now? So I hope everybody is now on one. We are now on the same distance, right? So we can move on. Let's look at the last, which is cluster sampling. The last we are going to discuss, cluster sampling method. In cluster sampling method, the units of selection are not the individuals. That's one important thing we must note in cluster sampling. The units of selection, all the while we were discussing, we were selecting what? We were selecting individuals. Is it not so? Yeah. But in cluster sampling, we don't select individuals. That is very important. So, what do we now do? We say the units of selection are not the individuals in the population, but the groups of individuals known as clusters. So in cluster sampling, we select clusters and not individuals. So we say the entire population is grouped into n distinct non-overlapping clusters. Why should this be non-overlapping? Or what do we mean by non-overlapping? Non-overlapping groups. One
sample is not belonging to the same group, into different groups.
I would have accepted what you said, because there is a wrong use of word that made me to turn my stomach somehow. You said, what do you mean by one sample?
Sorry, one individual.
So if you say if non-overlapping means that no single individual will belong to more than one group. Every individual in the population belongs to one and only one group. All right. So the entire population is grouped into n distinct non-overlapping clusters or non-overlapping groups. A sample of n clusters are selected from the population of n clusters, and all the units in the selected n clusters are included in the sample. In other words, included in the study. That is the cluster sample. Is that clear? I will give an example. Maybe in a study, I have decided, or someone has decided to study maybe it could be carried out any study on several hospitals. Okay? Let us assume that in that study area there are 20 hospitals. I hope you are following. Which means individuals that are to be included in the study belongs to either one of these 20 hospitals. Is that clear? Then, but it is important that you know that the population of these hospitals need not be the same. I'm sure you know that. They need not be the same. Maybe in one hospital there are 20 persons, in another hospital there are only 5 persons, in another hospital there are 70, and so on and so forth. Do you understand? But also know that we have 20 hospitals in that study population. Then we want to use simple random sampling method, and we want to decide. Let us use a simple, maybe let us select 5 hospitals out of these 20 hospitals using simple random sampling method. So we select 5 hospitals out of the 20 hospitals. Then these hospitals selected, we will now go into the hospital. Hospital 4, you are selected. How many individuals do you have? They have 20 individuals. 20 of them are included in the study. Is that clear? Hospital 8, you are selected. How many individuals you have? Only 80 individuals. You are included. We will continue until the 5th hospital selected. Whatever is the number of individuals, they are included in the study. At the end of the day, by the time we add the population of hospital 1, population of hospital 2 selected, population of hospital 3 selected, until population of hospital 5 selected, if you add up all of them, that becomes the what? The sample size. Is that clear? That is the cluster sampling method. The only challenge with the cluster sampling method is that in cluster sampling method, the sample size is not known before sampling. Okay? That is the only challenge with the cluster sampling. And because of the fact that maybe in your study program, you will need to determine your sample size and agree on the sample size with your supervisor before you will go into the field. Because of that, you cannot determine the sample size when you are using cluster sampling. You only get to know the sample size when you get to the field. I don't know if you've understood. This is the cluster sampling method. I hope there's no question on that. Is there any question? No question. So that is the cluster sampling. And I want to add that cluster sampling can as well be in stages. And when it is in stages, so we have what we call multi-stage cluster sampling method. How do we mean by being in stages? It is possible that in these 20 hospitals, when we go to each hospital, we can group them again. Maybe, assuming we are interested in health workers, okay? There are 20 hospitals that have different categories of health workers. We may decide to go to these various hospitals. And when we get to them, those 20 of them, we now again have another categorization. And when we talk about another categorization, there could be any other natural grouping that can be applied there. And one possible natural grouping that can be applied if you get to a hospital, it might be that maybe you are interested in grouping these workers with respect to maybe which, okay, okay, good. Maybe their work. Assuming the workers we are talking about, they have different works where they belong. That is assuming. Is that clear? So you can further group them into what? Works. And when you are grouping them in that way, let us assume that in those 20 hospitals, there are maybe 10 wards in each of them. Is that clear? And because of that, you have selected, first of all, you will select 5 hospitals out of the 20. When you have selected the 5 hospitals out of the 20, out of those 5 hospitals you have selected, you will do again another word, selection. Let's also assume you are interested in selecting only 2 wards out of the 10 wards in each hospital. Or out of the many wards in each hospital, you are selecting what? 2 wards. So out of the 5 hospitals you have selected, you will come and select only 2 wards from each of them. Is that clear? That is now the second stage of cluster sampling. So all the personnel in those 2 wards you have selected for each of those 5 initially selected hospitals, they have become what? Members of your sample. I don't know if it's clear. In this case, it's a 2-stage cluster sampling. They can as well be 3-stage cluster sampling. They can be 4-stage and so on and so forth. You have a question? All right. I said it is using simple random sampling method. And you can use simple. He said? Yes, the hospitals are 20. So, in this case, you can use that lottery method we talked about. Since we know the hospital, there are 20. We can number them 1, 2, 3 to 20. Or we can use their names. We have 20 pieces of paper, right? Where their names are written. We can have them fold 20 pieces of paper. Maybe put it like this and put it like this and pick one. You select it. We can carry all of them again. Reshuffle them, pick another one. We draw. By the time we have picked the 5th one, when hospital X is selected, that's one. Do you understand? By the time we open 5 from them, those hospitals are in stage-wise selection. That is the first stage. We move into the second stage until we are done. Then those all that are selected will be selected in the sample. Yes.
My question is, you said that if someone is carrying out a work, the supervisor might want to know the sample size. Does it mean someone cannot use this cluster method for her study?
Okay.
We may call them.
The answer is yes and no. You can use it if your supervisor permits it. But in this case, as you are using it, there is no issue of what sample size are we going to use. Is that clear? There is no issue of that. All that we know is that I'm using cluster sampling. That is the method I'm using. And when you get into the field, whatever becomes the sample size, that is what you will work with. Okay? So it's not a case of I want to determine the sample size I want to use with my stuff. So it can be used if you are supervising.
Is this general formula for determining sample size?
Maybe you will tell us. Tell us the formula.
And we're not saying that there's issue like The study I will try to carry out involve hospital, and like you were saying, there's no how I can know the population. So in course of literature, I now discovered that some people that carried out similar research, they use a formula. They say that you use it in cross-sectional study.
Because you are giving a partial information. You know why it is
I
not.
don't want to ask you if there's something like that. If you can.
You saw it in a paper and you're asking me, you want me to say no, that you didn't see the paper, or that what you saw in the paper is rubbish.
Yeah, whether it can
Okay, no problem. I've noted, but if you had given up the formula, that would have helped us. But you don't have the formula. All the same, we have noted, hello, sorry, we have noted it, okay? Before the end of our stay today, maybe we will answer it. All right?
Sorry. Just question. I asked you this question yesterday, but you promised me that I should ask it today. So now other people will hear. The question I want to ask, since we are still dealing with sample, and you want to do a pilot study, how do you determine the sample size of your pilot study? Thank you, sir.
You're welcome. We have not finished the sample size for the main study. We have brought that on the second pilot study. I have noted the question. Hello. I have noted the question. Before the end of our stay today, we will address it, okay? I saw a hand this side. Okay.
Very much, though I had
I'm sure I can barely hear you.
Okay, my question is, when you choose these two words from each hospital, this 5 hospitals, you choose 2 words, and then everybody in that word is selected. Do you now call that your sample size for the population when you want to present it?
Okay, thank you. The answer is simple. What is population and what is sample? Population is the totality of all the units that we are studying. And you know already that there are many words. And out of those many words, you chose 2 words. So it cannot be population, no. Rather, you go to each of those 2 words we selected and look at the individuals in those 2 words. Assuming in the first word there are 2 persons, in the second word there are 4 persons. How many do you have there? There are 6 persons from that particular hospital. You go to another hospital, assuming there are 15, you have 15 persons from the second. 15 plus 6 is what? 21. You go to the third hospital, go to the 2 was selected. Assuming there are 20 persons there, you have it. 20 plus 21 is what? 41. You go to the 4th one, go to the 5th one. By the time you have gone through all of them and added all the individuals in each of them, let's assume that at the end, you've got 70 persons. So your sample size have now become what? 70. There are the 70 persons you are going to study for the work. Has that answered your question? Okay. All right. We still have noted all the issues raised this time. We will attend to that. I have finished that. So we want to look at determination of sample size. Determination of sample size. So, the sample size is used to study a population. We know that very well. And it is important to have N. I don't know that I want to, the standard notation for sample size is small letter m. Okay? So from now, let us know that the notation for sample size is what? Small letter m. Okay. So anywhere we see small letter m, so long as this workshop is concerned, let us note it to be what? Sample size. Just as population size is denoted or symbolized with capital letter M. So anywhere I see capital letter M, I should note it to be what? Population size. Is that clear? Generally speaking, in statistics, small letter M represents sample size. If I'm reading any material, any article in statistics, anytime I see small letter M, I already know that it is sample size. Whereby it is going to denote something else. Maybe the author of that will do what? Will specify what it means. But this is not specified. Anywhere in statistics I see small letter M, it stands for sample size. All right, so a sample is used to study a population. It is important to have N that will be adequate for the study. In other words, there are some N values that may not be adequate to a particular study. Do you agree with me? Okay. Time will not permit us to go into the nitty-gritty of the damage or harm that inadequate sample sizes do to a study. Time will not permit us. Being not adequate means that they can be less than what is required. It can as well be what? More than what is required. Whether it is less than what is required or it is more than what is required, two of them represent what? Inadequacy. Also, okay. So because every study about a population, on the basis of the sample from the population, introduces a measure of error into the findings. This is what makes the statistics different from any other or different from pure mathematics. What is that makes it different? Statistics or statistical findings go with what? What we know as margin of error. There is no statistical finding that is error-free. It's important that I tell us this. You didn't hear what I'm saying? No statistical finding is error-free. You cannot say that I have found out this, and I'm 100% sure that that is what it is. It is not true. Such a thing is not statistics. In statistics, we deal with margin of what? Error. But the only thing that we do in statistics is that we come up with the findings, statistical findings that have reduced error, that we can be confident that this finding is with certain percentage of what? Of assurance. But no statistical study is 100% has 100% assurance. Because of that, of a sample that will give maximum allowable error. In other words, there is a size of sample that one may choose that may introduce what? So a very big error to the study. While there is a size that will introduce just a minimal error. Everything we do in statistics is to try to do what? Try to limit the error. Try to make the error margin to be as small as possible. But there is no study in statistics that has ever come up that has what? That has eradicated error. Is that clear? The reason is because statistical findings are based on samples. And because they are based on samples, and we know, for one population, just the population that I remember that she asked about, maybe assuming there is 1,000 persons in the hospital, and she has selected a sample size of 370. We can select several different 370s out of 1,000. Is it true? maybe when we have a set of 371 has selected, if we change 20 persons out of that 370 and get another 20 to replace them, that is another size, another sample. Is it true? If somebody decides to change 2 persons out of them and they bring another 2 persons to have another 3, that is another 370. Is it true? So we'll have several different sets of 370 that can be selected from each population. So that you have used this particular set of 370 to conduct your research doesn't mean that that is all that can be used. So the finding that you have got from in that research is to a large extent dependent on the sample that you have used. To the extent that if we had used a different 370, maybe you would have got something different. Is that clear? Because of all of this, we try to use a sample size that will be able to reduce the error, but no one can eradicate the error. They cannot reduce it. So, in order for us to have a sample size that will be adequate to reduce the error to a size that can be accommodated in a research, we will be able to be looking at a size that will be adequate for each study. If we use too small a sample size, the error will be what? So much. Is that clear? If we use so large a sample size, we would have done what? We may have introduced serious wastage. Something that you could have done with 200 and achieve a result that has a minimal error. You decide to increase the sample to 500. It is the same result that you are going to get, but you understand that the cost of recruiting people, members, into a study that you would have wanted would have been doubled, or if not tripled. And as a result of that, it amounts to total what? Wastage. There's no need to waste resources. And because there's no need to waste resources, we need to do what? Use as small sample size as possible. So I can put it here that the higher the sample size, the lower the error. That is true. The higher the sample size, the lower the error. That's a study that she painted that we are using 370 to do. It will have an error. If someone decides to increase the size to 500, the error will reduce. And someone decides to increase the size to 700, the error will further reduce. And someone decides to increase it to 900, the error will further reduce. And if the person decides to use all of them, 1,000 of them, the error is eradicated. Is that not so? But it's no more statistics. Why? It is now just ordinary what? Ordinary survey. It's no more statistics. Because what the statistics does is that statistics looks at any population on the world from the side of the sample that is selected from it. Is that clear? So that is what is true. The higher the sample size, the lower the what? Error. It is known. Now, as a result, too low a sample size may render a sample survey result less precise. In other words, too erroneous and hence useless. If there is a lot of error in the result, that result cannot be used. It becomes useless. But again, however, too large a sample size may also result in the waste of resources. The sample size is obtained for either mean-based studies or proportion-based studies. When we are talking of maybe too large a sample size, for instance, yesterday I talked about destructive what did I call it? Enumeration. Do you remember? I told us maybe it's so that it is destructive, that for you to get the information from each participant, that participant will die in the course of it. Such studies, you cannot even use large sample size for such a study. You understand? Let's leave human beings. But I know one destructive sampling that is done in the industries. For instance, if you open this, sometimes this bulb, you will see bulb. Sometimes they will put the, what is it called? The total voltage of the bulb. Sometimes they will put the lifespan of a bulb. Do you understand? How did they get to know the lifespan of the bulb? There's no other way they knew it except by doing what? By subjecting it to tests so that they will be able to determine it. And how do we do it? For that bulb, for one to know the lifespan in the company where they manufactured it, maybe for you to know the lifespan, you will get the bulb, plug it on, and begin to load it with voltage, begin to increase the volts. As you are increasing the voltage, it continues to increase until before you know it, the bulb will do what? It will burst. The total voltage at the point of its bursting is used to determine its lifespan. But until it bursts, you will not be able to determine its lifespan. You understand? So if the company that manufactured this bulb wants to determine the lifespan of the bulb that they manufactured, and they decided to use all of them, at the end of the day, no one will come to the market. They have produced and they have destroyed all that they produced. Do you understand? So to do such a destructive, maybe sampling, you will need to reduce the sample size as low as possible, so that maybe in a batch of 1,000 bulbs that they have produced, they may decide to randomly pick 10 and then destroy them. When they have picked 10 to destroy, they will be able to get the voltage of each of them. Now, when they put them together, take the average of all of them, they use it to do what? Determine the lifespan. And whatever lifespan that they have determined, from those 10 that they destroyed, they used to do what? Generalize for the entire batch of 1,000. That all of them have this lifespan. Is that clear? Another good example is in the industry where they manufacture elastic. You cannot determine the strength of an elastic unless you do what? Unless you stretch it. Yes. And after they manufacture it, for them to know the strength, each one they pick, they will load it with a force that will do what? Will stretch it. And the force will continue to stretch it until it will lose its elasticity. Have to do what? To sell. So such enumerations, they are destructive. And when we encounter and when we get involved in a story that involves destructive enumeration, we have the sample size to be as small as possible. Now, there are so many methods for determining the sample size for a study. But I want to bring this to majority of the studies that we embark upon, majority belong to two different classes. The first class is mean-based studies, and the other one is proportion-based studies. And in each of them, we have a method of determining the sample size. Again, there are different formula for determining sample size, but some of them require the knowledge of the population size. But again, there are situations where you cannot know the population size. You understand? Maybe you want to study, maybe, what did I say at this point? You want to study maybe cases of diabetes, maybe in the elderly, for instance. You can say in Enugu State, for instance. Is it possible? Do you know the number of people, the elderly people suffering from diabetes in Enugu State? Do you know them?
Yes.
There's no such record anywhere. And because there's no such record anywhere, you don't know the population size. Is that clear? But does it now mean because you don't know the population size, you cannot determine the sample size? No. There are some formulas that have been obtained that makes use of the population size, where there are some. In cases where population size is not possible, there are certain formulas that have equally been obtained to determine the sample size without the knowledge of the population size. So, that's basically what we have here. So N is also obtained based on whether N is large or small. Again, there are situations where we have what we call large population size and small population size. All of them put together. Then the sample sizes are obtained as follows. What I have here is not exhaustive. If we search through various materials, even till today, I'm still saying, because it's important I mention this to us, even till today, works are ongoing. It is still an open research to determine what? Sample size for different studies, especially in health sciences. So many persons have come up, I have read about various methods of determining sample sizes for different studies. Some will give, maybe for cohort study, they will give a sample size determination. Maybe for a longitudinal study, they will give a sample size determination. For this other one, they will give a sample size determination, and so on and so forth. Is that clear? I will not go into the rigor of getting sample size determination for each specific thing that we want to do. Is that clear? And even for the ones I have presented, what I have presented is simply mean-based study and the proportion-based study. We have sample size determination for them. In the cases where the population size is known, and the cases where population size is not known, we have sample size determination for them. And yet again, these depend on the authors. Because like I said, it's an open research. Some persons sample size. I don't know if it's clear. If I am, unfortunately, I'm not in sample survey. If I am in the sample survey, maybe I would have developed one method or two for determining sample size, a particular study of another particular study. But I'm not in that area, so I don't have the limit. But it's just to tell us that it is an open research. Even if you, what is important is that any sample size determination formula you are using, you can just say that according to so and so, that we will have this sample size determination and use it. I hope it's understood. Okay. So, we are going to present for the mean-based research. What do you mean by mean-based? Where someone is interested in getting average of that. Is that clear? For such a research, the first one, if one is interested in looking for sample size when there is a single mean, we have number one here. N is equal to Z1 minus alpha over 2 multiplied by sigma, that is sigma, all divided by E, and all raised to power 2. And what is each of them? Where Sigma 1 minus alpha over 2. Sigma is a point which, if you like, you may call maybe a point under the standard normal curve. Most of you know what a sigma is, except that the way it is presented, you don't know. If, for instance, you are doing a test, if you are doing a study where I would say, maybe I want to use 5% level of significance, I'm sure you will do such a thing. Good. So in a 5% level of significance, it means that the sigma 1 minus over 2 is 1.96, which I'm sure that some of you have seen. Is actually something like that 1.645, 1.28, and so on and so forth, depending on the level of significance. Then what is sigma? Sigma is the standard deviation of that particular population. The standard deviation of the population. But this is when, if the population is known, and one can determine its what? Standard deviation. Is that clear? But in most studies, in real life, the population is not known, and as a result, one cannot determine the what? The standard deviation. Is that clear? In such a situation, that will lead us to estimating the standard deviation. And when it is estimated, it is replaced here. And what is E? E is simply margin of error, or what you may call error margin. E is the error margin. What is the error margin that we want to use for this particular study? That is what E will be, the error margin. And what do we mean by error margin? Error margin simply means what? How precise, or how close whatever information, how close is this? Don't know that, whereby whatever value we are going to get will not be what? Too far away from the actual value. Is that clear? As a result, we determine the error margin that we want to give for this particular study. And once it is determined, whatever it is what is going to be put here. And then when we have it raised to power 2, whatever thing we get from it becomes the what? Becomes the sample size. Let us use a simple example. Are we together? It is better we pay more attention to my explanation. Pay more attention to my explanation so that you understand. Let's assume that we want to carry out this study using maybe 5% level of reviewing. Our Z 1 minus alpha over 2 is what? 1.96. Unfortunately, I don't have any table, a standard normal table. If I have one, I would have shown us how to read to find that 1.96. But I should have a textbook in my system that has the table. Okay, let me finish first. If I finish, maybe I will project it. So what am I saying? Assuming, so it is 1.96. Let us assume that the standard deviation is 10. Okay? I will put it here. That place where I have Z1 minus alpha over 2 is 1.96. The sigma there is what? 10. So I will have 1.96 times 10 will be what? Somebody should help us. 1.96 times 10. Is what? 1.96 times 10 is 19.6. I will ask myself, what maximum error can I allow for this study? Let me assume that I want to allow a maximum error of 3% for this study. Is that clear? Are we together? So 3% maximum error is equal to what? 3% is what? 0.03. Is that clear? So I am going to divide 19.6 by what? 0.03. So divided by 0.03. This will be equal to 653. Is that taken? It is equal to 653. Then I will multiply it, but I will square it. So 653 will be raised to power what? 2. And if I raise it to power 2, I will be getting approximately this times I'll be getting 126,000. 1.96. That is said, it is very substitute 1 minus alpha over 2. So they are together. So what I have done now is very simple. Don't mind the result that we got. Don't mind the value that we got. What is important is to understand what we have done. You said what? I said that Z of 1 minus alpha over 2. If the level of significance of my study is 5%, which means I have alpha equal to 0.05. Alpha equal to 0.05 means that my Z1 minus alpha over 2, if I read this from the table under the standard normal curve, I'm going to get 1.96. Okay? Assuming the standard deviation is 20, everything I'm talking about is an assumption. Assuming the standard deviation is 20, then I will say assuming it is 10, that was what I used before. I will now say 1.96 times 10, which is 19.6. Now, assuming I want to have a maximum allowable error of 3%. 3% is 0.03. So I will divide 19.6 by what? 0.03. And that will give me 600 and something. Then for me to get the sample size, it is that 600 and something raised to power what? 2, which means 653 point something times itself. And that will give me this value that I just mentioned. Then that is what? Just a demonstration. I'm not saying that when you do your own, it's going to be this value, but it's just an instance. I don't know if it's understood. And because I have got that, I will now say that, therefore, my sample size for this study is equal to that. And that's what I'm doing into this trade. Is that clear? I'm sure it's understood. Okay, somebody is raising hand. Yes. Not you. I saw someone there. You, yes.
Okay, sir. I want to ask, this maximum allowable error, do you determine it on your own?
Yes. Let me say you determine it on your own. Not on your own as an individual, but with the help of your supervisor. Okay? You determine it. For instance, let me give an example. You want to do a work, and this work that you want to do, the error there is up to 10%. 10% is 0.1. You and me know very well that the error is high. You understand? 10% error is high. And because it is high, what it means is that you are doing a work that has a chance of being wrong up to 10%. Also that we are health sciences. Maybe someone who is introducing a drug and says that, and someone carries out a research on the drug and says that this drug is better than every other drug that is in existence for curing that particular ailment. And the error margin there is 10%. Can somebody take such a study to be serious? No, because the error margin is too high. It is high, too high to be an error margin. And as a result, the error is meant to be as small as possible, so that one will be able to do what? Have maybe the finding to be something that one can look at and say, yes, that this is what, this is acceptable. Now, that is by way of answering your question. But then, for me, or to me, yes, I know that there is a formula for getting this error margin. Because the error margin is nothing but the standard area under the normal curve multiplied by the standard error of the estimate. I know that, but you will not know it. And at the same time, to determine the standard error, its formula has a sample size n inside of it. So if you don't know n, how can you introduce it into the formula for you to be able to find the standard error? You find out that it is a recursive something, that you want to find something, you are getting a formula that contains that which you don't know. So you cannot find that. So in other words, the simplest answer I can give is that it is determined. You determine, specify the error margin that you want to have. Most of the times, it is recommended that no study should have more than 5% of error. Do you understand? So assuming you have a 5% of error, so that 5% is equal to what? 0.05 that the error margin will be. So any study that has more than 5% of error margin, such a study cannot be taken seriously, especially that it is in health sciences. Health sciences is an area of study that one shouldn't joke with when it comes to specification. Is that clear? So if you make a specification that has more than 5% of error, what it means is that any of your findings shouldn't be taken seriously. At least the error margin shouldn't be more than 5%. Okay, now your question.
My question is, you said like the sample size we got from this example is quite large.
Yes.
And you said you shouldn't mind. And then I'm just looking at what to make the difference between this example and my own work. If I will not get something as large as this one.
Thank you. What will make a difference in that place which we have looked at? If you look at that standard deviation, we set it to be 10. Okay? You and I know that that formula that we have there is actually a ratio. Because it is something divided by something. Is it not so? And we know in a ratio like this, we know number one thing we know is that the higher the denominator, the less the ratio. Is it not so? Or the less the quotient. Is that not true? That's number one important thing we know. Number two thing we will know there is that the smaller the numerator, the smaller the quotient. Is this true? And the higher the numerator, the higher the quotient. We know all of this. So having known all of them, one can specify maybe the error margin to be a constant, as I have used to be what? 3%. And the level of significance can still remain 5%. Is that clear? But the standard deviation, we know that the smaller standard deviation, as we have it there, the smaller the value. I am sure that if we change this standard deviation to 5 and you do the computation again, you will definitely get a smaller value. And I know that if you go further to reduce it to maybe 3, you will still get a smaller value. If you reduce it to 1, you will still get a smaller value. Is that clear? Unfortunately, it is not for me to specify. Let me do it so that the standard, assuming standard deviation is this. You understand? So, it is not the best practice to say assuming standard deviation is this. Rather, because I don't know the standard deviation, it can be estimated. And how do we estimate it? That is where pilot study comes in. That is where pilot study comes in. So for a study like this, for me to even determine the sample size, I need to estimate some parameters that I will need to use in the determination of the sample size. From the results I have got from my pilot study, if I have conducted a pilot study, from the other pilot study, I will be able to do estimate the standard deviation. And whatever thing I have got from the standard deviation, I can now use it to determine my sample size. Is that clear? So, the remainder, all the other ones will follow the same procedure. Every other one there, they follow the same procedure. And when we have it, that is what we know. This is one way of determining the sample size. And all of them are dependent on the population size, which is capital M. I will go again to say that there are situations where the population size is not known. And when that happens, this other author, Kirkwood and Stein, they did a work in determining the sample size, the work they did in 2003. And they obtained these two formulas, 1 and 2. 1 for mean base and 2 for proportion base. Here, they have U plus V all raised to power 2 multiplied by the variance now. I'm sure we know that the standard deviation raised to power 2 is something as variance. See what I'm talking about? Okay, unfortunately, we cannot see. What I'm saying is that formula, can we see U there? Yes. Can we see V? The next value outside that bracket, that is sigma square. Okay? Sigma is a Greek letter, and it is normally used in statistics to denote many things. There are different, just in English letters we have lowercase and uppercase. Is it true?
Yes.
In Greek letters, we equally have lowercase and uppercase. This sigma that we have here is a lowercase sigma, which is normally used to denote standard deviation, or rather population standard deviation. But if it is uppercase sigma, that is what we normally use to denote the symbol of what? Summation. Do we remember symbol of summation?
Yes.
That symbol of summation, which is like this, is equal sigma, but is uppercase sigma. While this one that is here is lowercase sigma. Uppercase sigma is used to denote summation sign, while lowercase sigma is used to denote standard deviation of the population. So this is what we have. Then divided by mu minus mu naught all squared. And what is this? It is actually here mu naught. Mu is equal to another Greek letter. In statistics, we use so many Greek letters to do some symbolic symbolization. Here, these letters are mu and the mu naught. Mu naught is specified mean. Why mu? is like a sample mean. So that difference is what? The difference between the population mean and the sample mean, which means the higher that difference, the more the what? The error. I don't know if it's clear. Sample mean is meant to be what? Meant to approximate for the what? The population mean. Something that is being used to approximate for something is expected to be as close as possible to that it is what? Approximating. Is it not so? But we know that it is not always, it cannot exactly be what? The same. So, that difference is the same thing that we talked about, the error. That is the error margin. So one can give this error margin. Saying, for instance, I want to do this, I want to obtain the sample size such that the error margin will not be more than 3%, for instance, which means the whole of this thing under here is going to be what? 0.03 raised to power 2. If we raise 0.03 to power 2, it should be giving us 0.0009. That's what it should be. And that is what you should have as implemented, depending on what you have specified. Is that clear? But what we have on top there are the things that are very important for us to look at. We have specified that sigma is the standard deviation. That one, I said, can be estimated using the what? Is the one sample, or maybe, how do I call it? One thing, or one-sided value that can be obtained from the standard normal curve. V itself is the two-sided value that can be obtained from the standard normal curve. Assuming that we are studying this again under level of significance of 5%, let us do this study using our alpha, level of significance to be what? 5%. And 5% is 0.05. Is that clear? Our yield, if we check it from the paper, is supposed to be 1.28. And our V is going to be what? 1.96. Is that clear? When we add the two and multiply the two by whatever is our variance, which is sigma squared, then divide it by 0.0009, whatever it gives us becomes the sample size. Is that understood? This is a method that can be used. So, the way you are reacting to this, that means all this time I have taken to do this explanation is just in this. I want us to .96, and that is equal to 24. Supposing I have the variance of thread, I will multiply this by what? Thread, and that is 9.72. Okay, 9.72. Now I want a maximum allowable error that can be introduced in this study to be what? 3%. Are we together? Now 3% is what? 3% is 0.03. I want to raise it to power 2. And that is equal to 0.0009. Remember what you said before? 7.4. When we said 1.28 plus 1.96, what did we get?
3.24.
Multiplied by 3, we got what? 9.72 divided by 0.0009. That is equal to 10,800. That becomes my sample size. She shouted at because she wants us to have a sample size of 59. Maybe so that she will say yes. What I have done is just an example. And this example, if the variance is reduced further, we know that this thing will continue to reduce. Is it not so? Depending on whatever thing we found to be the variance. But that is the sample size determination according to these people. And the sample size determination is important. I say this. The only thing that we need to do is to look for a sample size determination method or formula. It is enough for me to do what? For me to cite that method. If I have cited it and I use it, whatever thing it gives me, I can go ahead and make use of it. You understand what I'm saying? You didn't get what I said. So what else do you want me to say? Maybe I would, when we assume we didn't discuss the determination of sample size. Let's assume we didn't discuss it. We did not spare. So in this case, we will spare it. Do the sparing. No, it's increase. How can you reduce? That is for mean base. The next one we have under it is for the proportion base. And having said all of this, in health sciences, as I know, so many authors have produced different sample size determination formulas. Okay? The only thing that we need is to pick any one and use that one. If it gives us a sample size of 10, we go ahead, because what I know is that any person that wants to embark on a study, they want the formula that will give him or her the smallest sample size. We don't need to labor too much, because suffering is not good. That is true now, suffering is not good. So we don't need to labor so much, especially somebody by this side. She is concurring with everything I'm saying. But suffering is not good. If we can get a formula that will give us a sample size of 20 for our PhD study, for our MSc study, all that we need to do is to do what? Provided they will have cited that from the source. Cite the source and use it. It is acceptable. Is that clear?
Yes, sir.
But we must we should be able to cite the source. Why I'm saying it is very different to formula for doing what? Determining sample size according to so many sources. So just cite the one that you want to use and go ahead and use it. Whatever thing it gives you, you make use of it. I'm sure it's clear.
Yes.
So I have given a soft so going to this was method of data collection. Unless if there is any question. If there is none, okay.
I'm not getting it very well. How we can determine this out of the result
To us. What is standard deviation? So what is measured? So what that is exactly what standard deviation does, and it has a formula. But unfortunately, I don't have formula for standard deviation because I didn't know there is a question that can be asked, and we don't have an interactive board. As you have an interactive board, I don't know if it's there, but I'm sure that all of us, starting from our secondary schools to the our undergraduates, we took maybe a course or courses in statistics, and we were taught measures of the deviation. And one of them is standard deviation, and you know the formula for finding the standard deviation. Okay? So, have I answered your question, sir?
yes. Yeah.
So, please, thank you so far. I want to ask, the first form formulas you gave them, you see that mean for mean-based study. What about for population-based?
Four of them are not for new based. The first two are for new based, while the last two are for proportion based. Number one and number two are for new based, and number four are for proportion based. Because even in that number three, you will see something like in the formula. Can you see P there?
Yes, sir.
P is the proportion. You can see it in number three, you can see it in number four. Number if you go to number three, it is talking about the mean place. So the proportion place. When the sample size is large. While number four is the proportion based when the sample size is small. Same way, you go to 1 and 2. 1, 2 is mean based. So let's say for example, when the population size is large, number 2 is the mean based. When the population size is small.
Popular
In determining standard deviation, you can use pilots. What of if
Looking at me, because your headache has been on pilot study. Agreement. and to amend to repair the instrument. Okay. So he has presented that one important essence of pilot study is for validation of instruments. Is it not? That is the point he has made. That is for validation of instruments. Yes, I have another hand.
From studies that have experienced, I've stayed there correcting someone that pilot study is different from pilot testing. And now, the essence of pilot testing is to get the reliability of the items or the instruments used to connect them. So I want to know the difference between pilot
Can you come again? He said, let me maybe relay the ones I got. That there is a difference between pilot study and pilot testing. Good. Continue from that point.
And essence of pilot testing is for the reliability of
Is for
reliability
okay, reliability of the instrument. Yes.
data connection.
Yes.
Example question. So I want to know the difference between the two. Pilot testing and study. Now, but I'm very sure of that of testing. The reason or the essence is to tell you reliability.
Okay, thank you. 10 minutes time. You have something to say?
Whether a pilot study will be also referred to as you want to test run let's say a system or a situation to see whether you're able to scale with the data.
I was thinking that you are trying to answer the question she asked.
No, I'm asking.
I'm asking another one. Okay, if you're asking a question, then let's take it. Can we have one house? She is asking a question, and the question is pilot study and pilot testing. It depends on the source. When I was teaching yesterday, I said something that I don't say that something is wrong because I may not know the source from where that thing is coming from. Is that clear? I can't at this moment begin to say that this is not correct or that that is correct because I don't know the source. Having said that, I personally I don't know what is pilot testing. That is the simple truth. Maybe she has given me an assignment that I will go and do the research to see what the pilot testing is, because it is not known to me. What I know before now, which I have taught, which I believe I understand, is pilot study. In that study, the essence of pilot study, number one, is to validate the instrument. Number one. Number two, to estimate for parameters in the population that may not be known. And then, number three, to have an overview of what is needed in the entire study. That is to say, the tedium involved, the difficulty, everything that, because somebody may sit down and design a wonderful study and he has not looked at it to know that this and this and this may not work out fine when I go to the field, only for the person to move into the field and discover that those things are not working that way. In such a situation, the person cannot come back and say that I'm not going again. But it is through pilot study that one will be able to know the nitty-gritty of what is involved in even collecting the data. So these are the three important things that we we get to know through the help of a pilot study. That is why it is an entire study. It is a study because we are studying the target population to know. Do you know it is possible, for instance, that you have in your questionnaire, which is an instrument that you want to use in the study, but the target population, the target audience, they may not understand a particular thing in that your instrument. Do you understand? It is through pilot study that you'll be able to discover be able to get the results I needed. So that one has got to know that through pilot study. All of these are the things I know about pilot study. So, but you have given me an assignment to go and check differences between pilot study and pilot testing. And I will do that. Okay? But there was a question that was asked me before it went down, which has not been addressed. Can I remember that question that was asked here? There was a question that was asked here. Okay.
We're asking if it's a percentage or a number.
Okay, I have answered that one. Okay. Methods of data collection. Methods of data collection. You already on break now. So that you want us to break now? Everybody will say yes. Okay. Ask you. Okay. Somebody has asked another question. Why others have break? And I want to respond to that. She has asked a question that is it advisable to use a different set of individuals for pilot studies other than the set that is used for the main study? And this question, I understand where it is coming from. It is going to come from the fact that we are going to do pilot study to fulfill all righteousness. That is where this type of question will come from. I don't know if you understand what that means. When I am doing a pilot study to fulfill all righteousness, I may have come to the field to collect my data. And when I have done that, I will decide, let me select 50 of them and then put them to test to be able to say that I have this result, I have that result. So when I have finished it, it is to fulfill all righteousness because it is not addressing the purpose of pilot study. How do I mean? Pilot study is meant to be done, concluded, first of all, and this result presented. And when it has been done and the result is presented, now, if everything is okay with the result, we can now say it is now time to do what? To do the main study. It is it's just every 10 years. So by the year 2016, supposed to have conducted another what? Census. Even though it was not conducted then, until after I think about 2020 something, they said they want to do census. And I have some people even went for training as ad hoc staff. At the end of the day, that was cancelled again. Now, in every census year, there's something that is normally done. Pilot study is normally done during census. Is that clear? And in this pilot study, they will select, like in Enugu State, for instance. I remember in 2006 census, there was a pilot study that was done in 2005. And this pilot study was done in 2 local governments in the whole of Enugu State. I still remember that one was done in Usuwan local government. Another one was done in local government. There were pilot studies. And when they concluded that, they were able to do what? Ascertain the validity of the instrument that they had prepared for the main census. Now in 2006, they now went into the main census. And can I ask a question? Usuwan, local government and Ogun, were they excluded from the main census? No. They were not excluded. So, I don't know if that is answering your question. You have a population you want to study. If you are going to do pilot study the way it should be done, you go into that very population using the sample size to do what? To get information from some individuals. When you have finished that, you have reported it, and if everything is okay with your instrument, you can now go back into the same population using now a sample size larger than that of pilot study. Is that clear? It is possible that someone who was part of the pilot study will equally be part of the main study. Is that clear? Such possibility may exist. But in such a situation, there is a real pilot study. But if we are doing pilot study for the purpose of fulfilling our righteousness, we have gone to the field. Maybe we have 300 data sets. And I will suddenly remember that I will need a section for pilot study in my work. I will now decide, let me select the first 20. Let the first 20 organizations be for my pilot study. And I will now use it to do all the things I need to do, and I will report it. If you start a situation, it is not a pilot study in the sense of pilot study. So the sense of pilot study is the one I have told you. And having told you that, I think I have answered that question. So this is the new part one. Yeah, you should have finished your day because it's such a long time.